Hi, I'm going to be talking about right-hand rules and left-hand rules for a conductor to figure out which way the magnetic field is. What you first got to understand is there's two different ways of looking at current flow. Some of you are learning, where you're studying from a textbook, that current flows from positive to negative. Some of you are learning from a textbook where the current is flowing from negative to positive. As a result, we have two ways of doing this. So all you got to do is find out whether for your course you need to use the right-hand rules or the left-hand rules. They're basically the same thing, you just got to make sure you use the whichever hand is appropriate. So I'm going to talk about both of them. So here's an example showing current flowing through a wire. When electricity flows through a wire, it creates a magnetic field. It doesn't create a magnet, it creates a magnetic field. It's sort of like when electricity flows through this wire, it creates a donut-shaped ring around it of a magnetic field. And what a magnetic field means is if you put a compass near there, it's going to be influenced to point a certain way. And that's what we want to know. Which way is that field? Which way will a compass point? So the left-hand rule or the right-hand rule, depending on what your course uses, shows us which way that is. So here's a wire. Electricity is flowing this way. When electricity is flowing this way, I use my left hand, and my thumb points in the direction of the flow of electricity, and my fingers in the direction of the magnetic field. So here's the wire. Here's those kind of donut-shaped fields around it. Which way is that field? If I put the wire here and I put my hand where my thumb points in the direction of the direction of flow, then I wrap my fingers around it. The fingers are going up on this side, around over the top, and down at the bottom, at the back. So my field is going this way. Okay? So my field is going that way. That means if I put a compass this way, it's going to point that way, and I'll talk about that in a second. If I was told, no, I'm supposed to be using the right-hand rules, then again, the electricity may be flowing this way. You put your fingers around it, you grab it so your thumb is pointing in the direction that the flow of the electricity is, and you put your hand around it. In this case, it's this way and around. So in that donut-shaped magnetic field, which extends out and gets weaker, the field is around this way. So there's a couple of ways we can look at it. We can look at the wire this way, or we can look at the wire straight on. If we look at the wire straight on and we want to know what that donut field is doing, we need to have a way of indicating that the electricity is either going this way in the wire towards me, or the electricity is going this way in the wire away from me. For electricity coming towards me, for electricity going into the board here, we mark that with an X. For electricity coming out this way, the wire is sitting this way, and the electricity is flowing towards the camera, we put a dot. That's how we indicate it. And how you're going to remember that is, if you shoot an arrow, if the arrow is coming towards you, you see the point of the arrow. If the arrow is going away from you, you see the tail feathers of the arrow. So this is like an arrow going away from you and an arrow going towards you. So let's extend that for a second. Here's a wire, and the electricity, the wire is sitting like this. The electricity is coming towards the camera. So which way would the magnetic field be? Is it going to be around this way clockwise or around this way counterclockwise? Because that's my donut magnetic field there. Well, if I'm using the left-hand rule, my thumb points in the direction of the magnetic field that's towards the camera, and my fingers are curling this way. So the field goes around that way and around that way. The field here is clockwise. What does that mean? Well, if I have a compass has a north and a south. A compass is just a magnet, and it has a north and a south, and it swivels. It can rotate around. If I put that compass here, the north of that compass would point this way, in the direction of the magnetic field. That's what the magnetic field is. It's how would it influence a compass. If I put that compass here, the field is to the left here, so if I put a compass, it would point that way. What's the direction of the magnetic field around this one? Well, if I use my left-hand rule, it's a piece of wire going into the board, so my thumb goes into the board, my fingers curl around in the direction of the magnetic field, and in this case, it's counterclockwise. So the field is going around counterclockwise. If I use the right-hand rule, the field would be going the other way. Well, is that what actually is happening? No, because remember I said the right-hand rule and left-hand rule depend on which way the electricity is flowing. And so, in actual fact, the electricity will be going the other way. Don't be confused. just use the same rule, and the direction of electricity will be determined, and which rule will be determined by your teacher, whether you're using the right or left hand rule. So my thumb into the board, left hand rule. My thumb into the board, counterclockwise, which means if I put a compass here, it would point that way. So this is the left hand rule or the right hand rule for electricity flowing in a wire. It's not a compass, it's a donut-shaped ring around it of the magnetic field. If I want to make it into a north and south and make a magnet, I have to loop it like this. Once we get loops, we get a magnetic field. And in the next video, we're going to talk about how do you determine which is the north and the south.